Namaste. This is a short video in which I would like to share with you the greatest achievement of my life so far. I'm going to do a screen share and present a few slides to you. Hope you would know something new about me that you didn't know. So let me start. You see the photo of the underground train, and the project was called Microtrac. Microtrac was a turnkey project undertaken by NGEF Electric Factory. This was to provide the underground metro train for Calcutta, India. This project used a programmable logic controller, or PLC, to control the train. The PLC would accept commands from the train driver and control the traction motors. So what's the big deal, you ask? This was a very exciting project, as it was the first underground train project for India. Most importantly, all the lives of the passengers of the train were in the hands of the program running on the PLC. An electromechanical system that was used to accept drivers' commands and control the train was being made obsolete by the manufacturer, and hence a replacement was urgently needed. What were the challenges we had? Traction principles and how the metro train works had to be understood first, so as to be able to intelligently answer the questions the customer may raise about our product. It was required to develop a diagnostic system which can prove to the metro officials that our Microtrac behaves exactly as required. It was required to source all hardware and software for the diagnostic system and write all the software for the diagnostic system. A lot of data had to be acquired. 48 digital channels which had on or off status of various switches within the control of the train. 8 analog channels. These were voltages applied to motors, current drawn by them, speed of the train, etc. All the data had to be stored on the hard disk at the rate of once every 15 milliseconds. This was a very tough requirement, as the available technology at that time was predominantly Intel's 8086 processor-based computer. All this was to be done while the train moved at 60 kilometers per hour under the control of Microtrac, and show live data in a graphical way. The computer had to not only acquire data at a very high rate, but it also had to display graphs and charts with the live data at the same time, while the hardware is already under stress due to the moving train. The metro train had a very tough operating cycle. The train had to start moving, reach a peak speed of 60 kilometers per hour, and then smoothly decelerate and come to a perfect stop at the next station, which is only 1 kilometer away. The braking involved regenerative braking, where energy was put back onto the power grid. I led a team which designed and implemented a diagnostic system after procuring the necessary hardware and software. I wrote all the software components and helped the hardware team to develop the necessary hardware interfaces. Another member wrote the PLC program, and I was often called to solve some logical problems and suggest suitable alternative approaches to arrive at a solution. In this photo, you can see my manager capturing some live data on a slowly moving train using the diagnostic system I created. Notice the charts being shown on the monitor. The software was designed to show them in color, but a color monitor was too bulky and delicate for use on a moving train. LCD monitors were yet to be invented, you see. The blue box under the table is a constant voltage transformer which was stabilizing the power coming from the generators on board the train. As these generators were designed for simple lighting, voltage and frequency regulation was not really a design criteria. So we had to protect the computer from unstable power supply that had lots of surges and spikes. The software was written using Borland C++ and assembly language. Data acquisition cards on ISA bus were used to acquire data from the traction motors and other hardware on board the running train at real time. Interface device was designed to convert signals that were at 750 volts DC to those acceptable by the PC. This is one of the photos we were allowed to take on the train showing the internal control systems. You can actually see only my right hand operating the computer keyboard, while with my left hand I had to prevent the programmable logic controller unit from swinging wildly. This unit had to be mounted on a hinge as the interface cables were coming from the back of the unit, and the whole unit would swing wildly if not held by hand. There were cables and interfaces which would have provided some support, but we did not want to risk it. You can see my colleague holding the monitor down in place as it would have lurched out of the table when the train moved and went through the tough duty cycle. You can also notice the skeptical expression on the face of one of the railway official who wasn't really happy about us taking a photo, nor was he initially confident about our test. He was half expecting the whole thing to fail. Here you can see the faces of the railway officials and myself showing the diagnostic to them. As you can see, the formerly skeptical railway official has now turned around and is watching with interest. The person sitting next to me is the person who was in charge of the whole project, and he was the one who signed the purchase order and the check soon after this demo. It was a check for 60 million Indian rupees. 60 million. 60. He was also so happy and confident with our demonstration that he said that he is putting this same train on active service at 5 p.m. during the peak time the next day. And he asked two of us to be in the driver's cabin just to make sure everything went well. He had already signed the check and handed it to us, So we were not that concerned about the purchase order itself. But we were naturally scared because we were the ones who wrote the software and designed the hardware, and we had no way of imagining what could go wrong when thousands of people piled into the train at peak time. Thrilled and scared at the same time. But the live service went very well indeed. And I'm here to tell you about the whole project. This has been the greatest achievement of my life so far because of the challenges we faced and what we achieved. The check that we received for the company was enough to pay the salary of over 6,000 employees for 1 month. I'm certainly proud of this achievement. Wouldn't you be? Thank you for listening to me. Hope you know something about me now.